Okay, that is encoding, the process by which information gets into memory storage. The first main processes involved in memory system. The next is storage itself. How we, after we get all of this information, after we pay attention, after we decide on which information is important for us to understand and to store it, how our mind, how our brain process this information and keep it in our brain. Okay, so in this part, we are going to look into three systems which involve in storage, which are sensory memory, short-term memory, and long-term memory. So the first one, memory storage, keeping what is important. Storage is basically refers to our ability to retain the information. Okay, storage is the retention of information over time and how this information is represented in our memory. Okay, like we have discussed before, information that we've seen and we've heard is not stored the same way in our brain. So our brain interpret them and keep them, and we want to recall it back, we are able to do it. Okay. According to Atkinson-Schriffen theory, our memory storage involves three separate systems. Okay, the one that I mentioned just now. Okay, memory storage system involve sensory memory, short-term memory, and long-term memory. Sensory memory is basically a fraction of a second to several seconds. Okay, basically when we sense the information. Short-term memory is up to 30 seconds when we process the information. And long-term memory, some would say that basically there is no time limit for it. Okay, up to a lifetime once we are able to store the information in our long-term memory. Okay, so this is the diagram represented what Atkinson and Schriffen's theory talk about. Sensory memory, short-term memory, and long-term memory. So all of the information that we hear, or we listen, or we read, or we see, all of these will come to our sensory memory and we will process them through attentions. And if we decide that that information is important, then we are going to bring those information into process in short-term memory. After that, after we have decode, okay, we have understand, we have elaborate those information, we are putting that information into our long-term memory. And when we want to recall, when we want to explain, when we want to share the knowledge with others, the information with others, the experience with others, then we retrieve information from long-term memory to short-term memory. So this is the diagram represent the three systems, sensory memory, short-term memory, and long-term memory. This is explained by Atkinson and Schriffen theory. Okay, let's look at one by one. Sensory memory. So in this part is similar to sensory information or sensory detection, whereby we detect what happened around us. Okay, we sense what happened around us. In sensory memory, it's basically the first stage of our memory system, whereby we detect information that are sent, that are available. Okay, when we hear, okay, when we listen, when we read something, for example. Okay, at this stage, the point at which information enters the nervous system through sensory system. Okay, in sensory memory is involve holding information from the world in its original sensory form. Okay, if we listen to audio kind of informations, so we retain in that form. If we see something, image, say we retain in image form. Okay, in video form, for example. But the duration is very quick. Okay, it's for an instant only. So no researchers or cognitive psychologists, they say that not much longer than the brief time is exposed to the visual, auditory, and other senses. It's a very brief one. So there are two types of sensory memory. Okay, there are two types. One is iconic sensory memory, and another one's echoic sensory memory. So iconic sensory memory refers to informations that are visual based, okay, visual information. On the other hand, echoic sensory memory refers to hearing information, audio type of information, information that we hear or we get from our auditory system. So these two type of informations involved in our sensory memory. So how can we differentiate between echoic memory and iconic memory? So in terms of understanding these two different types of sensory memory information, we can look into type of information, capacity, and duration. Okay, in terms of auditory sensory memory, it's basically the brief memory of something a person heard. Okay, something person hear. Okay, so basically audio-based type of information. On the other hand, like I mentioned just now, iconic memory refers to visual sensory memory, lasting only a fraction of a second, what we can see. In terms of capacity, there are two different capacity in terms of echoic and iconic. Echoic memory is limited to what can be heard at one particular moment. Okay, what we can hear. Okay, so it's very limited as what we can see. Okay, smaller than the capacity of iconic memory. While iconic memory, everything that we can see is basically enter our sensory memory. In terms of duration, okay, for iconic memory, it lasts longer. Iconic memory, we can see a lot, we can sense a lot, but it retains only for about a quarter of a second, 0.25 seconds only. As compared to echoic memory. Echoic memory, it lasts longer in our sensory memory. Okay, some researchers say that it lasts from 2 to 4 seconds in our sensory memory. Example given in our main reference book, okay, they say they put on the experience of seeing and listening to birds. Okay, both can be refers to the same object, which is in this case bird. Okay, bird can sing and we can hear the sounds of bird tweeting, okay, tweeting and chatting and singing while we are walking. Okay, example, you are staying in hostel, so you are walking to the class, for example, and then you hear the sounds of the bird, so you can detect directly it's basically a bird. Okay, on the other hand, some people see the birds without hearing the sounds of the bird. So these are basically two different types of sensory information. Okay, for auditory, we can retain those informations much longer. Okay, 2 to 4 seconds. For visual, okay, someone who see that, we can see a lot, but actually it's retained much briefer, okay, about quarter of second, 0.25 second. If in class, I will usually ask students to discuss about this scenario. Okay, if you remember about Alan's Pavio dual code theory. Okay, so how come Alan's Pavio dual code theory stated that we, as a human being, we remember pictures better while our sensory memory can only keep visual memory for only 0.25 seconds. Okay, on the other hand, we keep information from auditory information, okay, the words, okay, the lecture, for up to 4 seconds. But as human being, we remember picture better as compared to we remember words. Okay, we remember speech. Okay, we remember something that we hear. Why? Okay, so it's a food for thoughts. Have a think about it. We are going to discuss later about this perspective. Okay, coming back, short-term memory. Okay, so we have sensory memory, we have short-term memory, and we have long-term memory. Short-term memory. So sensory memory is basically we sense the information, but now we are going to process the information in our short-term memory. So short-term memory, or the short form STM, is the memory system in which information is held for a brief period of time while being processed. So it's basically the key here is in our short-term memory, we process those information. Sensory memory, we only sense, we only detect the informations. For short-term memory, it's basically limited capacity memory system in which information is usually retained for only as long as 30 seconds unless the person employs some strategies to retain it longer than 30 seconds. So remember, in sensory memory, we retain it only up to 4 seconds. Okay, if it's echoic memory system. Okay, if it's iconic memory system, then we only able to retain it for 0.25 seconds. When we decide those sensory informations are important, then we are going to process them even further. Okay, this is the production line. Okay, so we are going to take up to 30 seconds to process them. According to George Miller, one of the cognitive psychologists as well, the usual limit on how much information people can keep track of without any aids or without any technique or strategies is usually 7 plus or minus 2 items. Okay. On the other hand, this means that for a normal person, when they knew or hear or listens to new information, they will be able to retain up to 9 digits if it's numbers, up to 9 words if it's a sentence, up to 9 information of pictures at one time. Okay, because of what? Usually people remember 7s plus 2 or minus 2 is 5 to 9. Okay, this is for normal people. How George Miller coming up with this figure? Because they conducted memory spans research. Okay, where the number of digits an individual can report back in order after a single presentation of them. So they presented list of numbers to people and they asked all of them to recall these numbers. So it's basically on average people are able to recall 7 digits, but the least people can remember is 5, the most is 9. So it's 7 plus minus 2. Okay, if you remember, we are able to retain information for up to 30 seconds if we do not use strategies. Meaning that there are techniques, there are strategies people can use to improve the capacity of their short-term memory. Okay, so improving short-term memory, we can at least do 2 things. One is chunking, another one is rehearsal. So what is chunking? Chunking is a method where we can group or pack informations into higher order units that can be remembered as a single unit. Okay, acronym for examples. Okay, previously I do not know what's the meaning of FOMO. Okay, say for example, FOMO is a concept, fear of missing out. So it's quite mouthful to remember fear of missing out. Okay, this is just an example. So what people do, we create an acronym for that. Fear of missing out. So we take all of the first letters and then it's become FOMO. ASAP, as soon as possible, for example. So it's an example of chunking. Okay, I do remember during when growing up, when learned about rainbow colors. So people start to make words of it, okay, use techniques, okay, try to take all of the first letters of each color to make as a chunking. Okay, it's a technique to improve our short-term capacity, okay, short-term memory capacity. Another technique that we can use is rehearsal. So what is rehearsal? Rehearsal refers to the conscious repetitions of information. We repeat it again and again and again. Okay, within that 30 seconds, okay, when the information, okay, especially when you studying or revising, okay, introduction to psychology, for example. So you want to remember the concept, okay, short-term memory, short-term memory. So if you read it the first times without paying attention to it, you're already paying attention to it because you know that you want to memorize them. Okay. So you read the first time. Okay, short-term memory refers to a system, blah, 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 blah. Okay. In order to retain those 9 informations, longer in your short-term memory, what you can do is you can repeatedly redo or recite that sentence so that it will stay in our short-term memory longer than 30 seconds. Okay, chunking is a bit of information are combined into meaningful units or chunks so that more information can be held in our short-term memory. Okay, while maintenance rehearsals, okay, use repetition, practice of saying some informations to be remembered over and over again in our head, in our brain, to maintain it in our short-term memory. This is an important topic, okay? If you are someone who really likes to talk about memory or to study about memory, I need to mention this. Previously, there are quite a number of experts or researchers. They think or they say that short-term memory is equal to working memory. However, our main reference for this course does not regard working memory as the same as short-term memory. Okay, for Ciccarelli, okay, the books that we are referring, working memory refers to higher order processing. Is involved in short-term memory is basically but not the same as short-term memory. Okay, working memory according to our textbook is not the same thing as short-term memory. Okay, remember that it's not the same thing. So working memory is basically a combination of components, including short-term memory and attention. Okay, so working memory is not only about short-term memory, but a combination of components, which are involve short-term memory itself and attention, which allow us to hold information temporarily as we perform cognitive tasks. Okay, in order for us to understand, in order for us to relate to other things, in order for us to decipher that, to identify how many concepts, how many elements in that. So it's involve a combination of several components. The two components must involve in that is short-term memory and attention. So in this working memory is a kind of mental workbench or mental blackboard, a place where we can imagine and visualize. Okay, where the brain manipulates and assembles information to guide understanding, to guide our decision making, and to guide our problem solving. So working memory is best explained from Bentley's model. Okay, Alan Bentley's model of working memory, where Bentley's consider our working memory as a three-part system. Okay, three-component system. Okay, according to Bentley's working memories model, in our working memory, which is a higher order process, involve short-term memory and attention, we have three subsystems. One is phonological loop, second is visual spatial sketchpad, and third, central executive. Okay, the key is central executive. Okay, what is phonological loop? Okay, phonological loop is a briefly taught speech-based information. Okay, speech-based information consists of an acoustic code and rehearsal, what we hear. Okay, besides this speech-based information, okay, we also have visual or spatial information under visual spatial sketchpad. Okay, this system stores visual and spatial information, including visual imagery. Okay, its function independently of the phonological loop. Okay, it's not similar. It's totally two different systems. We have system that in charge of what we hear from and what we see, okay, from our visionary system. Okay, and the most important system is central executive. Okay, in this system integrates information from phonological loop, what we hear, and the visual spatial sketchpad, what we've seen, and long-term memory. Okay, so it's important. Why? Because this central executive is the one who process information that we see, okay, and information that we hear, and then we relate this information from the available knowledge that we have from our long-term memory. So the central executive is the one who link the information, okay, try to interpret them, combine what we've seen and what we hear, okay, from our phonological loops and from our visual spatial sketchpad. So all of these are happening at the same time, and the one that process them are or is central executive. Okay, so this is Baddeley's models, where it's explained the difference between short-term memory and working memory. So according to this perspective, working memory is a combination of components, okay, involved in short-term memory and attention. Okay, so working memory is a system by itself, but it's not the same as short-term memory. Okay, that is for short-term memory, which also involve working memory. Okay, the place, the process, the system where we process the information to send it to our long-term memory, to keep it for longer term. Okay, now let's talk about long-term memory, the permanent storage of the information. So long-term memory is a relatively permanent type of memory that stores huge amount of information for a long period of time. Okay, why is put relatively permanent here? Because psychologists, cognitive psychologists, they are still debating whether information that we store in long-term memory can be deleted or can be forgotten, or it will be permanent. So we're not going to depth to that discussion or debate. Okay, so it's relatively permanent. And most of psychologists and cognitive psychologists, they agree that the capacity of our long-term memory is virtually unlimited. Okay, basically we can store a lot more information than computer can do. Okay, according to von Neumann, okay, he assumed that we never forget anything. But even considering that we forget some things, we can hold several billion times information more than a large computer can do. Okay, that's how unique, how advantageous, and how precious human brain is. Okay, we can store a lot of information, and this storage involved in long-term memory. Okay, basically in our long-term memory system, there are two main categories of information that we store. Okay, one is called explicit memory, another one is called implicit memory. Okay, for explicit memory, we can understand it as declarative memory as well. Okay, any information or memory that we can say it, we can explain it. Okay, that is the explicit memory. On the other hand, even without realizing it, we as human beings also store a lot of information in our memory system which are non-declarative, something that we cannot explain verbally. Okay, under explicit and implicit memory, there are other subcategories of information involved in this system. Okay, for example, under declarative memory, under explicit memory, we have episodic memory and we have semantic memory. Okay, I'm going to explain in more detail after this. We have episodic memory under explicit and semantic memory under explicit. Okay, episodic something of our experience, the history of ourselves. Okay, the stories of we growing up. Semantic memory, some things that we've learned about facts, okay, about events, not even about facts, about informations, about knowledge, about concepts. Okay, those are all explicit memory, declarative memory. Okay, under implicit memory, those are the memories that we cannot explain verbally. For example, procedural skill based. Okay, how do you explain You are able to write. You are able to button up your shirts. Okay, you are able to play your sports skillfully, to cook, for example. Okay, another types of implicit memory is priming and classical conditionings. So let's look at one by one. Okay, so the systems of our long-term memory, so it's divided into two main categories. Okay, explicit memory and implicit memory. For explicit memory, like I mentioned just now, it's declarative memory, the conscious recollection of information that can be verbally communicated. Okay, we can explain it to others. So under explicit memory, we have episodic and semantic. Okay, episodic memory refers to the information about the where, the when, and the what of life happening. Okay, the experience of us. Semantic memory refers to the memories, information about the knowledge about the world, the concepts, the theories, the perspective that you have learned. Okay, so beside the explicit memory, without realizing it, we also store a lot of information that are implicit. Okay, non-declarative memory. Memory in which behavior is affected by prior experience without a conscious recollection of that experience. We don't realize that we are able to declare them. Okay, we are able to do it because of these processes. Okay, among informations, among memories that's stored under implicit memory is procedural memory. Okay, memory about skills. Priming, okay, the activation of information already in storage to help remember new information better and faster. Okay, we prime the information. And third, the process of classical conditioning. Okay, remembers that in last chapter in learning, whereby we can learn new things through classical conditioning and operant conditioning. Operant conditioning using rewards, classical conditioning using association. Okay, during association, people usually do not know that they've learned that through association. Okay, they are unable to declare that they've learned that through association. Okay, example I give to my previous student is, we somehow learn to be impressed with others because of what they wear and what they use, for example. Okay, in certain countries, cars like Mercedes, BMWs are associated with higher status. Okay, why? These cars are regarded as expensive car. Okay, as an elite car, whereby only people of certain status are able to buy them. Okay, so what we do not know is, when we look at people who have high status, okay, who have higher status than normal people in a society, so they usually or always drive these type of cars. So later on, when we see cars itself, we respect the persons who drive that car, even though sometimes the person is not coming from the certain of the society. Why? Because we have been conditioned without realizing that we have been conditioned that higher status refers to expensive car. Okay, so those are examples of episodics. Those are examples of explicit and implicit memory. So in these slides is differentiate between episodic memory and semantic memory. Both of these under explicit memory. Okay, remember? So these are declarative memory that we can consciously explain and share with others. Okay, how can we differentiate between episodic and semantic? We can differentiate it first of all from its units of information. Okay, so under episodic memory, memory based on our experience, so it's involve informations, okay, experience about events, about episodes. Okay, while semantic memory, information is about facts, about ideas, about concepts, theories, perspectives. So all of those under semantic memory. Okay, so in terms of organization, how our brain, our long-term memory or episodic memory, they organize according. Okay, when did you receive your first degree? Okay, when I was 25 years old, when I was 30 years old. When did you finish your master degree? When I was 30 years old. So it's according to time. When the first time you met your spouse? When I was in my first degree, which is when I was 23, 24 years old, for example. So we store information about episodic memory according to time. Okay. While in terms of semantic memory, something we learn about theory, about concept, about perspective, about facts. So we store it according to concepts, okay, in our brain, not according to time. In terms of emotion involved in the memory itself, okay, how we store it, for episodic memory, emotion is very important. Okay, that's why we remember events, we remember stories that are emotionally imbued or emotionally or feelings, involve feelings a lot. Something which is traumatic also, something which is very fortunate or happy event. So we remember those. Why? Because emotion play important part in episodic memory. However, in terms of semantic memory, information don't play a big part of it. Okay, it's not really important. In terms of retrieval process for episodic memory, it requires effort from us to deliberately recall those information. Okay, in order for us to share our experience with our friends, okay, with our students, so we need some efforts to retrieve this information from our long-term memory to our short-term memory so that we can explain to other people, to share with other people. But for semantic memory, in terms, once we understand the concepts, when the concepts are linked with other concepts, when we store it in our long-term memory, it usually requires less efforts. In other words, it's automatic. Okay? When we talk about quiet quitting, automatic coming to our brain. What is quiet quitting? When we talk about positive psychology, so we can recall it automatically. Okay, unless we don't know about it. Okay, in terms of how we share this information with others, retrieval reports, people will start about episodic memory with this sentence. I remember that the first time I met my spouse, so they use I remember. While for semantic memory, they use the sentence as I know. Okay, I know that psychology or positive psychology is important in today's life because it's focused on the strength of human being. Examples. Okay, in terms of the application of episodic and semantic memory in education, episodic memory is not really important because it's very individualized. It's about events, history of a person, while it's very applicable for semantic memory when we want to teach about concept, theories, ideas, facts, and etc. In terms of intelligence, okay, how clever a person is, for episodic memory is not really relevant because it's about history, it's about experience, but it's really applicable for semantic memory. Okay, and at the same time for legal testimony, as episodic memory is admissible in court because it's based on experience, based on real events, but for semantic memory, it's not admissible in court. So those are the two the two categories of informations involved in our long-term memory system, explicit memory and implicit memory. So how these implicit, explicit, episodic, semantic, procedural, priming, or how this information are stored in our long-term memory. So researchers have divided opinion. Okay, so basically we take two perspectives which explain how human beings store this information. One is schema, another one is connectionist network. So let's look at one by one. So the first perspective that explains how human beings store information in their memory is from schema perspective. Okay, So schema is a concept, a pre-existing mental concept or mental framework that helps people to organize and interpret information. So schemas from prior encounters influences the way individuals encode and make inferences about and retrieve information. Okay, thing is like this. While we are growing up, so we are building a lot of schema and schemata in our brain. Okay, take example. Previously, when we are growing up, we have a very rigid concepts of vehicles. Okay, cars, for example. For a car, it must have tires. Okay, for tires, it must have air in the tires. For a car, it must have engine. For a car, it must have handling. Okay, must have steering. For a car, must have seating. For a car, must have what we call a gearbox. So that is the schema. So the first schema, when we growing up, we only have a schema of vehicles and objects that help people to commute from one place to another. Okay, and then we've learned that, oh, there are a lot more type of vehicles. Okay, you have cars, you have motorcycles, you have van, you have bus, you have boats, you have aeroplanes. So all of these develop from schema of vehicle. So under vehicle, we have schema of cars, for example. Now, with the technological advancement, people start to invent more environmental friendly engine. Okay, starting from the hybrid engines. And then with goes now, we have electrical engines. Okay, and towards, I've read recently, Honda have started to develop a more efficient engines, not depending on hybrids, not depending on electric, but depending on nitrogen. So a lot of technological innovation in that. So we have in our mind a mental concepts of vehicles and cars. So when you've learned that there will be a flying cars, for example. So flying cars is simple, cars without tires. So previously, we might not have the capacity to make sense out of it. But due to the technological advancements, okay, some of us even watch the prototypes of tires without air, cars without engines, cars without tires. So we can relate this new information with the available schema, with the available mental concept that we already have. Okay, so under schema, so we store information in terms of concept. We get new information, so we add on our mental concept. So we are improving. So we are enhancing our mental concept every day, every moment. So under schema, we have one specific schema which we call as script. A schema for an event often containing information about physical features, people, and typical occurrences. Okay, when we are driving and we pass through a public multi-purpose hall, okay, or we can simply realize, oh, basically it's a wedding in that place. Why? Because we have schema in our brain. If there is a wedding, people will wear a very lavish style, okay, very traditional style with musics, okay, with gifts, people walking with gifts, people come with family members. So it's types of schema, it's type of mental concepts. When these information are available, so we can directly understand that, oh, actually it's a wedding there. Okay, even though we do not know it's a wedding or not. Why? Because we have the script. A schema for an event often containing information about physical features, people, and typical occurrences. So that is one of the way, schema, one of the way human beings store the information in our long-term memory. So besides storing information based on its mental concepts, okay, the second perspective that explains about our storage system is through connectionism, okay, based or also known as parallel distributed processing. So according to this perspective, we do not keep or store the information based on its mental concept. Instead, this theory, okay, the theories, based on this theory, our memory is stored throughout the brain in connection among neurons. Okay, it's not about concepts. So basically, we have many neurons, thousands, billions, trillions of neurons in our brain. And each neurons have its own memory, have its own information. So when the new informations are entered or sent to our long-term memory, these new nodes, okay, new information will connect with other neurons. So several of these connections may work together to process a single memory. Okay, for you to remember about events, it's about people, it's about dates, it's about place, it's about color, it's about events, a lot of things. So all of these are interconnected in a form of network. So according to this connectionism perspective, memories are not large knowledge structures as in schema. Okay, it's not like that. Instead, memories are more like electrical impulses, okay, whereby it's organized only to the extent that neurons, the connection among them and their activity are organized. So how memory form? Okay, because, okay, for example, you have an accident, okay, Nauzubillahi min zalik. You have an accident, okay, you ride or you drive a car with your friend and then you want to go to a wedding and then you happen to have a road accident. Okay, sorry, unlucky to you. Hopefully you already have your meal. Okay, sorry. Okay, so how, according to this connectionism perspective, how do you create the memory? Remember, you have your friend with you. Your friend's already a neuron in your brain. Okay, names, the backgrounds, okay, the gender, all of that already connected neurons in your brain. So you are driving your car. It's your car, not your friend's car. So another neurons, another nodes in your brain. Okay, another not concept, another neurons. So these neurons are already connected. And then the event itself happened on the 23rd of November. So the dates come in. So connected with another. So now neurons of dates, neurons of car, neurons of a persons are connected. And then accident happens. So neuron of accident also involved. So 4 neurons are interconnected. Okay, what happened? Trauma. Okay, another neurons of emotion. So what happened? The person who involved, okay, a family involved in the accident as well. Another neurons connected. So a memory, according to connectionism perspective, is not about schema, but it's about the connections of these neurons. Okay, so memories are not large knowledge, instead it's electrical impulses. Neural activity involving memory is spread across a number of areas in our cerebral cortex. The location of neural activity called nodes are interconnected. When a node reaches a critical level of activation, it can affect another nodes across synapses. Okay, so these are why or how we store information according to connectionist network. Okay, so these are the you can look at this diagram representing the new electrical impulses, okay, and the neurons activation. Okay, so these connectionisms or parallel distributed processing, based on this perspective, memories are organized a set of neurons that are routinely activated together, and this process is known as consolidation. Okay, this process of connecting, activating multiple neurons at the same time is called as consolidation. Okay, the process by which interconnected networks are formed. When neurons continually fire together in the interconnected ways, a memory forms. Okay, consolidation are important for us to form a memory. Even though a memory may feel like one thing, actually, according to connectionism perspective, it is represented a multiple connected paths of network neurons in our brain. Okay, so memories are not stored in a specific location in the brain. Okay, memory storage is diffuse in many parts of our brain. Assemblies of cells distributed over large areas of the cerebral cortex work together to represent the information. Many different parts of the brain and nervous system are involved in the complex process that is memory. Although there is no one memory center in the brain, specific brain structure are involved in particular aspect of memory, okay, such as frontal lobes, episodic memory, amygdala, emotional memories, temporal lobes, explicit memory and priming, hippocampus for explicit memory and priming, cerebellum, implicit memory. So, it's even though it's diffuse across many factors, but this specific also important in terms of the structure of the brain involved in different aspects of long-term memory.